Now let's start talking a little bit about lightning. Well, what is lightning? Lightning is simply a discharge of electricity within mature thunderstorms. Now, lightning can occur within a single cloud, from one point of a cloud to another point in the same cloud. It can also occur from one cloud to another cloud, which is probably the most common type of lightning. Um, And then you can also have cloud to ground or ground to cloud lightning. You'll hear both terms, and I'll tell you the difference in a little while. But what is thunder? Well, let me explain thunder this way. When you have when lightning occurs, this electricity, a current of electrons flowing through the air, it heats up the air very rapidly. And so when the air heats up, that air is going to expand, like so. And so you just generate this wave of air. Now, after the lightning is over, it cools down quickly, and so you end up with collapsing air, collapses right into the center again. And so you have this oscillation of warm air being pushed out and then being pulled back in because of the cold air, and it creates a wave that propagates through the air. That wave hits our bodies, and our ears interpret that wave as sound. That's thunder. So thunder comes from the explosive expansion of air due to the heat from the lightning. All right, so what causes lightning to occur in the first place? It comes from the electrification of clouds. Here's what we mean. You have all sorts of different stuff going on in a thunderstorm. In this example here, we have a piece of graupel, which is warmer and heavier, so starting to fall, and you have a small ice crystal. Well, they're going to bang against each other, and due to the way that each one is built, one of them, in this case the ice crystal, is going to lose an electron and become positively charged, and that electron is going to go into the hailstone, which becomes negatively charged. Okay. Now, there are a lot of different processes. It doesn't have to be a hailstone and an ice crystal. It could be two hailstones bumping against each other. There are lots of different ways that charges can be separated. But the point is, one type of material is going to become positively charged, another one's going to be negatively charged. Okay, let's keep going with this example here. So you have an ice crystal that's positively charged, hailstone that's negatively charged, and you have an updraft pushing up on both. The hailstone is strong enough, it can resist the updraft, but the positively charged ice crystal keeps getting pushed up to the top of the cloud, leaving the top part of the cloud positively charged and the bottom part of the cloud more negatively charged. And in the area where it rains, yes, that can become positively charged rather frequently. But let's focus on the negatively charged side of the base of the cloud. Well, because that's negatively charged, it's going to take all the negative charges in the ground and push them away, and take all the positive charges and pull them up. So all these positive charges want to get close to the negative charges. Okay, so you're set up, you're ready for lightning to occur. Here's what happens then. So the base of your cloud is negatively charged, your surface is positively charged. The electrons are smaller, so they can move a little bit easier, and so they start to move around and try to search for a simple path to reach the positive charges. These electrons are called stepped leaders because they're leading the way for the current to occur, and they often branch out in different steps. Okay? As soon as they do complete a path, the positive charges can then zip up the lightning strike and that's where you're going to get the majority of your light, your heat. This is the primary part of the lightning strike right here. It's called the return stroke, where the positive charges return to where the negative charges started. This link here it's a really cool video here. Actually, the next page on Falcon Online for you has this video on it. It is a video of a lightning strike occurring at 7,000 frames per second, and you'll be able to actually watch lightning occur from beginning to end. Two things that I want you to do with that video. First of all, turn off the lights in your room. It's much more dramatic when it's dark. It's really fun. Second of all, notice how much time it takes. You'll see that one entire lightning strike, takes about 15 milliseconds. It's very fast. It happens so quickly. And think about that when you watch the video, that everything you're seeing takes 15 milliseconds. Okay, so this is what we call a cloud to ground strike, because the step leaders reach out from the cloud and go to the ground. Okay, so like I mentioned earlier, cloud to cloud lightning strikes are most common. Cloud to ground lightning strikes would be where the step leaders come from the cloud reaching towards the ground. But a ground to cloud lightning strike would be the opposite, where the step leaders come from the ground. The ground is negatively charged, and step leaders go up towards the cloud, which is positively charged. And then you get a return stroke the other direction. So that would be ground to cloud. Cloud to ground is much more common than ground to cloud. In other words, what we saw here in this figure is more common than its reverse, where the positive charges are in the cloud, negative charges in the ground. However, those ground to cloud lightning strikes can often become much more powerful. Those tend to be the strongest lightning strikes. All right, that's a simple lightning strike. You can have lightning that forms in lots of different ways. You have forked lightning. With forked lightning, you have more than one simple path. You have multiple paths, which you see very, very clearly. Often, I remember seeing a couple of forked lightning strikes where you could actually physically see the branches reaching out. It's one of the weirdest things, but really, really cool at the same time. You have ribbon lightning, where you have a lightning strike that occurs, and then a secondary strike that's parallel to it. It's ribbon lightning. Bead lightning, where the lightning strike is intense in some areas, but not as intense in other areas. So it kind of looks like a dotted line lightning strike. You have ball lightning. This is pretty well known. We're not going to talk about what causes it, but basically you have an electrified region in the air, and because it's electrified, it starts to glow like a lightning strike, but that electrified region is moving through the air. And you hear some really weird stories about ball lightning. I've heard one where someone was standing in their front room and saw a ball of lightning pass through the front of the house and out the back of the house. I don't know any more details than that. I'd have to know more than to tell you that, but that's the idea, is you just have this ball of electrified gas that moves through the air. Sheet lightning is commonly known. It's basically another term that we give to lightning strikes that happen within a cloud, because it makes the whole cloud glow, makes it look like a sheet. Heat lightning is lightning that you see in the far distance, and it causes glows around the thunderstorms, but you don't really hear thunder from it. Here's another one that's really, really interesting. This is called St. Elmo's Fire. What happens with St. Elmo's Fire is the tops of light poles, rods, they get electrically charged. However, when you have a pointed charge or a small tip at the top, charges can more easily separate themselves from the rod itself, and that creates a bit of a glow up on top. If you have a flat surface, a flat roof, you're not as likely to have charges fly off. But if you have this very small tip, charges do fly off. This was often seen by sailors, as you'd have a blue glow at the top of sailing masks. It's hard to see unless it's really dark, and so that's why sailors get to see it quite easily. So, yeah, the St. Elmo's Fire is a really cool thing to see. Sometimes you can see it if you look at the top of flagpoles during a lightning storm. Hopefully you're not outside during a lightning storm. But if you look at the top of flagpoles, you might see a blue glow. If you do, I'd suggest getting indoors pretty quickly. Yeah, that's a cool type of lightning there. There are other types of lightning that happen throughout the atmosphere. What we've talked about is lightning happening in the troposphere within a thunderstorm. But if you look at the upper atmosphere, you get other types. You get lightning reaching up into the stratosphere. That's called a blue jet. And sometimes you get these rings of lights, which are called elves, or these dancing vertical lights called sprites. Often seen, they were often seen by sailors, a lot of Irish sailors who had elves and sprites in some of their mythology, and so they said that they were dancing creatures dancing up in the sky, so you got elves and sprites, something like that. So you do get lightning that occurs not just in the troposphere and thunderstorms, but you do get lightning that occurs up in the stratosphere and mesosphere as well.